Hi there, and welcome back to VCE Master Academy. Today we are going to master the tangent function, often just written as tan. It looks a little stranger than sine and cosine, but do not worry. It runs on the very same idea, and by the end of this video, it will feel easy. Let us begin. So, what is tan? Here is the simplest way to see it. On the unit circle, for any angle, tan is just the y value divided by the x value. In other words, tan of x equals sine of x divided by cosine of x. You can also think of tan as steepness, how steeply the line from the center is tilted. A flat line has a small tan. A steep line has a big tan. Look at the unit circle on the right. Tan is that ratio, y over x. Now let us look at the graph of y equals tan x on the right. It has a few special features. First, it repeats every pi, so its period is pi, shorter than sine and cosine. Second, it shoots up to infinity at certain points. At x equals pi over 2, cosine is 0, and we cannot divide by 0, so the graph never touches those lines. We draw them as dashed vertical lines called asymptotes at x equals pi over 2, 3 pi over 2, and so on. Third, it crosses 0 at 0, pi, 2 pi. And unlike sine and cosine, it has no maximum or minimum. It climbs forever. That is the whole shape. Now, most tangent questions come dressed up in a general form. Y equals a, tan, n, t. Do not panic, it is just two dials. The a out the front stretches the graph up and down, making it steeper. But remember, tan has no top and no bottom. It still climbs forever, so a never gives it a maximum or a minimum. The range stays all real numbers. The n inside squeezes the graph sideways, and it sets the period. The period equals pi divided by n. The asymptotes, those forbidden vertical lines, sit at t equals pi over 2n, and then every pi over n after that. And the graph crosses the t-axis at t equals 0, pi over n, 2 pi over n, and so on. In short, t equals k times pi over n. Look at the graph on the right. Same tangent shape, just with these labels doing all the work. Before we solve anything, here are the exact values worth knowing. Tan of 0 is 0. Tan of pi over 6 is 1 over root 3. Tan of pi over 4 is exactly 1. Tan of pi over 3 is root 3. And tan of pi over 2 is undefined, because cosine there is 0. Keep these handy.
Example 1, an easy one. Find tan of pi over 3 and tan of pi over 6. Remember, tan is sine over cosine. For pi over 3, sine is root 3 over 2, cosine is 1/2. Divide them. The halves cancel, and we get root 3. For pi over 6, sine is 1/2, cosine is root 3 over 2. Divide, and we get 1 over root 3. Simple as that. Example 2, a little harder, solving an equation. Solve tan x equals root 3 for x between 0 and 2 pi. We know tan of pi over 3 is root 3, so one answer is pi over 3. But tan repeats every pi, so the next answer is pi over 3 plus pi, which is 4 pi over 3. Look at the graph on the right. The line y equals root 3 cuts the curve at exactly those 2 points. So x equals pi over 3, or 4 pi over 3. Example 3, 8R level. Consider y equals tan of 2x. The 2 inside squishes the graph, so the period becomes pi divided by 2, which is pi over 2. The asymptotes now sit closer together, at x equals pi over 4 and 3 pi over 4. Now solve tan of 2x equals 1 for x between 0 and pi. Tan is 1 when the angle is pi over 4, so 2x equals pi over 4, or pi over 4 plus pi. Divide everything by 2, x equals pi over 8, or 5 pi over 8. Check the graph on the right, 2 clean solutions. Example 4, the full transformation. Here is the general form, y equals a tan b times bracket x minus c plus d. Each letter is a dial. A controls how steep, B changes the period to pi over b, C slides it left or right, and D slides it up or down. Let us apply it to y equals 2 tan 2 bracket x minus pi over 4 plus 1. So A is 2, twice as steep. B is 2, the period is pi over 2. C is pi over 4, shift right by pi over 4. And D is 1, shift up by 1. The asymptotes land at x equals 0, pi over 2, and pi. And the curve passes through the point pi over 4, 1. There it is on the right, every dial doing its job. Where does tan show up in real life? Everywhere you measure a height or a slope. Say you stand 30 meters from a tall tree and you look up at the top. The angle your eyes make with the ground, the angle of elevation, is 40 degrees. Then the height of the tree is 30 times tan of 40 degrees, which is about 25 meters. That is tan connecting an angle to a height. Look at the triangle on the right. Tan of the angle equals the opposite side over the adjacent side, height over distance. Quick summary. Tan equals sine over cosine, or y over x. Its graph has period pi, with asymptotes where cosine is 0. It crosses 0 at 0, pi, 2 pi, and it has no maximum or minimum. For a transformed tangent, A is steepness, B sets the period to pi over b, C shifts sideways, and D shifts up or down. And in the real world, tan turns an angle into a height or a slope. Now it is your turn. Pause the video and try these 5. 1. Find tan of pi over 4. 2. Find tan of pi over 6. 3. Solve tan x equals 1 for x between 0 and 2 pi. 4. State the period and the asymptotes of y equals tan x. 5. A ladder leans against a wall at 60 degrees to the ground, with its base 2 meters from the wall. How high up the wall does it reach? Pause now. Ready? Let us check. Question 1. Tan of pi over 4 is exactly 1. Question 2. Tan of pi over 6 is 1 over root 3. Question 3. Tan x equals 1 first at pi over 4. Add pi for the next, giving 5 pi over 4. So x equals pi over 4, or 5 pi over 4. Question 4. The period of y equals tan x is pi, and the asymptotes are at x equals pi over 2 plus any multiple of pi. Question 5. The height equals 2 times tan of 60 degrees. Tan of 60 is root 3, so the height is 2 root 3, about 3.46 meters. Great work. And that is the tangent function. Remember, tan is sine over cosine, its period is pi, and it climbs forever between its asymptotes. You are mastering VCE maths, one concept at a time. See you in the next lesson at VCE Master Academy.